Hello everyone. Just going to have a couple of technical issues with the laptop. Okay, you ready? Good afternoon. My talk is entitled Components, 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 and I was thinking of doing a kind of a bar marching around the stage, getting everyone to shout components, but I'm British, I'm very reserved, so I wouldn't do that kind of thing. But I wanted to ask a question to get started. Who has seen a Rocky film? Hands up, anyone who's seen a Rocky film? Okay. Who could tell me the name of the main character, the boxer? Rocky Balboa, yes. So it's a pretty easy name to remember. He's the big fighter. He's the one everyone knows about, okay? And I like to think about Angular 2, which we've heard a lot about today, as being your Rocky Balboa character, okay? Now, who could tell me the name of Rocky Balboa's coach or trainer? There's a Mickey, yeah. So it wasn't quite so easy to remember. I certainly couldn't remember. I had to look it up on IMDb. So Mickey is the trainer, and he puts a lot of hard work in as well, but he doesn't get many of the plaudits because Rocky's the guy in the ring doing all the big hits, okay? So Angular 1, for me, is Mickey, right? In Japan, in Japanese, there's a term called sensei, and in general terminology it means like teacher, but it also means the one who came before, the one who was born before. And Angular 1 really is the one who was born before. It was born in like 2009, well, some of you people might have still been in high school, yeah? Angular 1 has been around for a long time, and I think Angular 2 has learned a lot from Angular 1. So I'm going to talk about Angular 1 today, and hopefully, even though there's a lot of excitement about Angular 2, you can bear with me and appreciate that there's some really cool things happening in Angular 1 still. So, big takeaway from today. Angular 1.5, this is the future of web apps. Yeah! Okay, maybe that's not entirely accurate. What I probably meant to say was that components are the future of web apps. And what you'll find is that if you look across many of the frameworks that are kicking around these days, they're all starting to talk a lot more about components than say, 12 months even ago. But the other thing I'd like you to remember is, from this talk, is that components love Angular 1.5. Or you could consider that Angular 1.5 loves components. It's a mutual loving relationship, okay, guys? So, who am I? My name's Pete Bacon-Darwin. I've been the lead developer on the Angular 1 team for about 18 months now. And in that time, we have seen a big change in the way that people develop JavaScript front-end frameworks or front-end applications, okay? And there's three things that I think that many of the frameworks are starting to converge upon. And the big one is that you build your apps using a component-based architecture, and that these components are formed into a tree, and that the next thing is that you can then use some kind of router to dynamically select part of that tree to render at any one point in time. And finally, that very large applications really benefit from a single directional flow of data through the application, which allows them to scale and be more easily maintained. So we've got this tree of components, but not every component has the same job to play in the application. And my thesis for today is that there are actually three different roles that components can play in any application. I've given them completely arbitrary names. There's various people talking about these kinds of things in the industry, and they've all come up with different names. So I'm going to try and mention all the different possible names. But there are these three types: presentation, business, and view. So let's look at each of them in turn. Presentation components, or sometimes called dumb components, or maybe even pure components, which means that they don't actually modify the state of the application themselves. They don't care where the data comes from, it's given to them, they then do stuff with the user, interacting with the user, and then they will emit some kind of output, like an event or something, to say that something has happened. But they don't know what the application is going to do with those events. Business components are like the glue between this presentation layer and your real business logic, which might be housed in an Angular application as services, say. These guys really do know where the data's coming from. They're responsible for going and getting it and then binding it to the presentational components. They're sometimes called smart components. I kind of think of them as impure because they do make state changes to the application. In Redux, they're called container components. Their job is not to interact with the user so much. Generally, their role is to render other components, whether they're other business components or maybe they are rendering the presentation components and binding them up. And then finally, this is probably the most contentious role, which I haven't seen written about anywhere. But when I've been thinking about components in my applications, this kind of role keeps coming back. And these are view components, which are specialized versions of business components. So they do know about data, but in particular, they know about the router, or they know about how to dynamically create this tree of components. And I think this is actually a really useful idea to consider. And if you think about your components in your application and split them into these 3 different ways, you can actually create much more maintainable and understandable applications. So as anyone who's done any work on Angular 2 or learning on Angular 2 over the last 12 months would know, the standard application is about heroes. And if you've been looking carefully, you'll know that my application for today is a villainy app. Because I'm not so chuffed about heroes. They're all wishy-washy. I'm much more interested in the villains. They're more cool. So I've created a nice application which allows me to manage my villains and favorite them and change their names. So you can see that I've got 2 views here. The dashboard just shows my favorite ones. It could have some other sort of widgets on it which would display perhaps the terrible things that these guys are going to do. And then I can actually go and edit my villains, and I can choose to maybe like some of them, and I can edit their name and change that one to Poison Frog or whatever, and you'll see that when I blur off it, it updates. So this application is built using Angular 1, but it's following this component-based architecture, and I'm going to describe some of those ideas to you today. So we're going to look at this particular view, this villainy editing view. The components that this view is created from include a my app, which is like the overall root component, and also a my villains component. These, for me, are the view components. These are the ones that interact with the router, and they are responsible for deciding what's displayed based on the URL. There's a My Navigation menu, which is just a simple presentation view. It just shows the buttons for navigating. But interestingly, you've got this list of My Villain components. These are presentation components. They don't know anything about where the data is coming from. My Villains is responsible for getting that data and binding it up to the villain component. So what's Angular 1.5 got to say about this? Well, Angular 1.5 is a culmination over the last 12 months of a lot of work by the Angular 1 team. Some of the guys are here today. And we've been focusing our efforts a lot on trying to close the conceptual gap between Angular 1 and Angular 2. Yeah, partially because we want to make it easier for people to upgrade from Angular 1 to Angular 2, but also Angular 2's got some really cool concepts in it, and if you use those in Angular 1, you're going to make better apps. Your apps are going to be better. And building component-based architectures has been a big part of that. So in Angular 1.5, we made it easier to define components, to create instances of them, and to test them. So if you think about what a component is in Angular 1, really it's just an isolated element component with a template and maybe a controller. You've been able to create these kinds of things since Angular 1.2 or maybe even earlier, if you can jump through the right hoops. And there's nothing particularly special about it, but it's a right pain to write them. There's a lot of boilerplate code, and you have to put in lots of things to do with binding to controllers or whatever. So we decided to create this component definition helper, which, using sensible defaults, allows you to create your components with almost like no boilerplate at all. And in fact, from the vast majority of components, you only have to give it a name, in this case, my component. you would provide it a template, because almost every component is going to need a template, some bindings, and your controller. And in some cases, like in a business component, you might not even have any bindings. So we've got this component that we can define easily, but they need to interact with the world around them. And there are 3 ways, basically, that you can interact from your component. So I've got a component here. It's got a parent component that contains it. It's got a sibling directive, like, you know, might have like a ng model or something. And then it wants to talk to a service. So the 3 different ways that you can communicate in an Angular 1 component is through input and output bindings, which are talking to the containing component. Dependency injection, obviously, where we get a hold of our services, and also requiring other directives in. So the input and output bindings, these are just basically like the scope, isolated scope bindings that we know and love from Angular 1. But in Angular 1.5, or in components, we automatically bind these to the controller for you, which is nice. We also expose the controller directly onto the template using $CTRL. So immediately you have access to your bound inputs and outputs on the template, and you can see here that I'm rendering the first name input, and I'm also then triggering the like output. Now you'll notice, if you've not been following along, we've actually added a new kind of binding in Angular 1.5, which we're calling one way. And what this means is that when you bind to the input, any changes on the outside get propagated inside, but if you change the value on the inside, it's not going to get propagated outwards. And this is obviously key to being able to create this one-directional data flow that I talked about at the beginning. You have to remember, though, of course, that if you're passing an object through, and this is true in Angular 2 as well, if you change the properties on that object, it's going to change wherever it's referenced. So you have to be careful about that. Dependency injection is still pretty much as normal, but what you'll notice when I had the component definition up is that we no longer require you to put in a factory function around the directive definition object. The component definition object just goes straight in. So that means we've actually moved some of the dependency injection into the things that need it. Obviously, as always, we can inject into the controller, but if you're defining the template via a function, then that's also now injectable as well. And finally, required directives. So we've always been able to require directives ever since controllers were added to directives. But it was always a bit of a pain to do that in an Angular 1.4 directive, say, because you would have to have a post-linking function which brought in the required directives. You'd then have to attach those to the controller and then probably trigger some function on the controller to tell it that it's actually now got those things. So we've updated the require property on the directive definition object, and also obviously on the component definition object. You can now pass in a hash object, and the value of the hash object is the require definition, which tells us that in this case we want to bring in the tab list directive. And the key will now be matched to a property on the controller. So then inside my controller I have immediate access to those required directives. You can see here also that I'm actually accessing this inside a thing called $oninit. So what does that mean? In Angular 2, there is a concept of component lifecycle hooks, and we've actually implemented a load of those in Angular 1 as well. $oninit that you just saw, this one gets called at the time when all of the bindings have been put in place. So you know all your input bindings are in place, you know that your required directives have been attached to the controller. So this is a great opportunity to then make use of those bindings and maybe do some extra work like downloading some data from a server, for instance. On $destroy, this one gets called when the containing scope that contains the component gets destroyed. So not when the isolated scope gets destroyed, but the thing that contains the component gets destroyed. I would use this to clean up any resources that I've created, or if I've created watches which are not specific to the isolated scope, then obviously I have to clean those up too. And now, the $on changes is my favorite hook that we've implemented this just in the last couple of months. This gets called whenever any of the input bindings change. And the parameter that gets passed in is a hash object which contains a key for each of the input bindings that have changed, and then the value of that contains both the previous value and the new value for that binding. This is an excellent opportunity for you to go in and compute properties based on the inputs. So in this case, you can see that we're noticing that the villain has changed that was bound to the myVillain component. And you can see then that we are computing the full name from this villain rather than doing that inside some kind of watch. And what you'll see in all of these examples so far, I've not actually referenced scope at all. And dare I say it, but we've almost killed scope. But rest assured, all of those people who are still desperately in love with scope, we haven't got rid of it at all. And of course, there are still quite a number of situations where you do still need to use the scope, obviously for broadcasting and emitting events on the scope. There are definitely still opportunities for you to set up watches and so on. But once again, like in terms of building components, we're trying to make things simpler, and for the vast majority of your components, you won't have to touch scope at all because you can use these lifecycle hooks, and you can use the fact that the bindings are set up for you onto the controller to make your life much easier. And you'll see that the code that you're producing is conceptually much closer to the kind of code that you're going to be writing in Angular 2 components. So, we're telling everyone that they should now build their applications using components, okay? So we thought we ought to make it easier to test them as well. So we've got this simple new $component controller service, which is in ng-mock. In the old days, you would use $controller to create yourself an instance of a controller, okay? But when I'm creating my components, I don't want to expose the controller in addition to actually adding it to my component. So this service allows me to specify the name of the component that I'm wanting to test, and we will automatically create you an instance of that component's controller. You'll see that there's no mention of scope here again. You can pass one in if you would like to. But you can see that this is like how you might go about testing a component controller. We're initializing the component with some, so we're pretending that we're setting up the bindings. We're calling $onInit to indicate to it that we've set up its bindings. We're then making some changes, triggering onChanges, and then checking that the onChanges has done what it's supposed to do. And last but not least, we have backported the component router to Angular 1.5, so you can use it in our applications. I have a little gripe. You might have noticed that I've been pronouncing router in a slightly strange and foreign accent. So I have this problem in meetings where people don't understand me, so I'm going to set the record straight now, okay? There are two kinds of router. There's the thing that you use to dig holes in wood, and if you look here, that is pronounced router, okay? But the thing which forwards data packets to appropriate parts of a computer network, or in our case, creates components in the tree based on some URL, is actually pronounced router. So if we go away from this conference with nothing else, I'd like you all to start using the word router. Although I have to make an apology. I did this search on Google, right? So this is the Google output when you type router definition. This is the thing that comes up in the nice box at the front. So it's official. It must be true. It was on Google. But obviously, I wrote this presentation while I was in the UK. And Google is sneaky, and they knew I was in the UK, so they gave me what I wanted, which was the spelling or the pronunciation that I expected. So when I was on the plane on the way over, I did it again when I was in the States, and came up with this. Now, for some reason, it's now rouder. I don't know why that's going on, but you'll see that I have to step back slightly. The second kind of router now has two pronunciations, router and router. But you'll notice that router is first. So, you'd make out of that what you wish. But of course, if you start using the word router, then you can fall into some potential problems when we have things like the root router. So I wanted to get in before Shai could on that one. But this is so problematic, the fact that everyone's going to have to start saying root router, that Mishko and Victor had to completely refactor the entire router system just so they could remove this concept from it. So the current Angular component router doesn't have a root router purely because it would just be confusing for people in terms of spelling. So getting back to the serious stuff, when you're defining your components in Angular 1.5, you can now specify your components very similar to what you do in Angular 2. You can specify your roots for the child. Now, I've left $root config in there because the current version of the Angular 1.5 component router, which you can access via NPM, still requires $root config. But obviously, very soon that's going to change to $roots. But you can see that we've got a very similar arrangement to what Mishko was just demonstrating earlier in terms of the way that you can configure it. It's conceptually nice and similar. Okay, so you can go and look at this code for this application. I haven't really got time to talk about it in detail today, but if you go to my GitHub account and go to ng component demo, then you can see it's all there. And you can see I've even written tests for it, and end-to-end tests, thanks to Jorge, who pushed me to do that. Testing, hey. So please go and have a look at that. If you want to read up some more on some of these ideas, and I'd be very interested in having a debate about the naming conventions and whether I've actually chosen an appropriate set. There's a great component guide for Angular 1 written by Martin Staffer. You can see some Angular 2 stuff here. There's a React thing there as well. Shh, don't. You can always just overlook that if you feel uncomfortable about that. And the last thing I want you to go away with today is to remember that web apps love components, and components love Angular 1.5. Thank you very much for your time today.